So in this session we are going to compare the results of answers with hand calculation. As you know, this as we do the sanity check in structure, we are also going to do the sanity check with the thermal calculations. So are the boundary conditions satisfied? Yes. So we have checked that wherever we apply the 20 degrees Celsius temperature, that in output also we are getting the 20 degrees Celsius. Right, so let's find out the verification steps. So here the temperature is 20 degrees Celsius at the boundaries, as we have applied essential boundary condition of 20 degrees Celsius here. If we'll compare the reaction on the left hand side probe, we are having a heat flow of 14406 positive, and here we are getting 14406 negative. So equilibrium is satisfied, whatever heat flows in goes out, right? So that's what the equilibrium satisfaction means. Mesh independence, as it's a very simple problem. By changing the mesh we are not going to get some good answer. So that exercise leaves upon you. You change the mesh, you might get the same heat transfer rate. The last part is of verification is comparing with the hand calculation, right? So checking and comparing with the hand calculation. We're going to do that hand calculation. So we should not forget that the convection is between solid and fluid, and conduction is in between solid. So here there is a convection on left hand side and conduction throughout the solid, right? So here two phenomena is happening. One is convection, another is conduction. Convection between solid and fluid, so there will be one thermal resistance, and within this solids we will have a conduction thermal resistance. So total thermal resistance will be the resistance due to convection, and another is resistance due to conduction. So this way we get Tf is equal to 800 degrees Celsius. T1 here we know it's 20 degrees Celsius. So we can find out the thermal resistance at any point. So let's find out surface temperature. As we are going to see, we have to compare it with the surface temperature with hand calculation. Let's first find out thermal resistance due to convection and thermal resistance due to conduction. So this is a formula for thermal resistance due to conduction and convection. You are already studied in your engineering. So let's find out what is the value. RTH convection is equal to 1 upon H into A. Remember boundary condition what we have provided. H was 30 watt per meter square degree Celsius. Area, as you know, that we have taken 1 meter square, right? If you remember that these are our three bodies. Height is 1 meter and thickness also we have provided 1 meter. So this heat transfer area is 1 meter square. So RTH convection is equal to 1 upon 30 watt per meter square degree Celsius into 1 meter square, right? So we get 1 by 30 watt per Celsius. Let's find out RTH conduction. We have three things, three walls. So we'll write L1 upon K1 into area is same, so I will not write A1, plus L2 upon K2 A plus L3 upon K3 into A. So this is area is 1, so that's not an issue. So L1 is 0.3 meters, right? Because K is in 25 watt per meter Celsius, right? So it's 25 watt per meter degree Celsius and it's meter. plus L2 is 0.2 upon 30 plus L3 is 0.15 upon 70. So this is equals to around 0.02080 watt per meter degree Celsius, and this is a 1 by 30 watt per meter get cancelled, so watt per degree Celsius, and here 1 by 31. So total resistance will be equals to this 1 by 30 plus 0.02080. So total RTH convection plus RTH conduction comes out to be 0.05414 watt per degree Celsius. Now let's put that in this equation number 1, right? So T1 minus TF, RTH convection plus RTH conduction. So Q is equal to T1 is 20 degree, TF is 800 degree Celsius. This we got as 0.05414. So if we'll calculate, we get minus 14406.3 watt, right? So that's the same what we got in answers. Just let's see. So in answers also we got 14406, and hand calculation also we got 14406.3 watt. So that was the verification part. Further on, you can calculate TS using any of the calculation. So let me take this equation number 3. I want to find out TS. So I know the Q is equal to TS minus TF upon RTH convection. This is 14406.3. TS is equal to, I don't know, minus temperature of fluid is 800, convection is 0.0333, right? So using this, right, so just remember here we have to put the minus sign. So if you put this and we'll equate that, we'll get 319.8 degrees Celsius, and that is what also we got in answers. Let's verify. In answers we got a temperature at surface as 319.79, same, and the exact answer we got using hand calculation also. So this is it. We have compared with the hand calculation and we got the same heat transfer rate and same surface temperature here. So that's all in this module of heat transfer. Next session we are going to see the natural frequency vibration analysis.